Hello, everyone, and welcome to the Engineer's Guide to Deploying AI Facial Recognition using NovaEyeD on STM32N6. So we've got a fantastic technical session planned for you today, packed with insights for anyone trying to get machine vision running on constrained edge devices. To begin with, I want to thank you for taking the time out of your day to join us. We all know that building a facial recognition demo in a laboratory is one thing, but actually then putting it into production is notoriously quite difficult. You know, whether it's curating data sets, optimizing for edge hardware, a lot of projects stall before they ever ship. Today, we're going to show you a proven path to deployment. So we're going to run a complete production-grade facial recognition pipeline entirely on an STM microcontroller. This means no cloud connectivity or external computer, and without any compromises on privacy. For those of you who have seen our webinar series or are new, this is an engineer's guide. And so we're going to be showing you technical demonstrations of exactly what we're talking about. We also have a series of direct questions that we're going to be asking our experts to get to the core of the technology. The format of the broadcast today will be a recorded video. However, this part is live, so I'm currently live at about 5 minutes past the hour. But what I will then show you very briefly is a recording where we will be showing you all of the information. You can still interact with us though, using the react feature in the bottom left next to the hand. I can demonstrate this now. You can react with several emojis, live, laugh, love, just like that. We're also going to have breaks in the recording for live polls. And at the end of the session, we will have a completely live question and answer for you to ask our experts any questions and get immediate answers. And the way you can do this is using the chat function in the top right of the GoToWebinar UI. Only myself can see these questions, so don't worry about anonymity. Before we dive into the recording, I want to test out this live poll function. And to that, I want to ask you guys the first question. And that is, what is your current experience level with machine vision? So I'll give you guys about 30 seconds to answer this. Let's see who we have here in the audience. You guys, another 15 or so seconds. We've got a good mix at the minute. Brilliant, brilliant. So I'm going to end the poll. So we have got a good mix of people in the audience, of people with no experience, a lot of people who are learning the ropes still, as well as a few people prototyping, developing projects, and people who've already deployed machine vision into production. If you're one of the 5 people who've already deployed it into production, welcome to this session. I hope you learned something useful, as well as everyone else. Now, I'm going to dive into the recording, but please stay with us because we'll be asking polls throughout this recording, as well as our live Q&A. So I'll see you soon, and I'll take it to Adam in the studio. So let's do some introductions. So to begin with, my name is Adam, and I will be your moderator for today. So I'm an electronics engineer with IP Exchange, and joining me are 2 experts who are making this on-device vision a reality. We have Vincent from STMicroelectronics and John from Embed UR. So Vincent, John, welcome. Vincent, you're already ready to go, so do you mind doing a quick introduction?
Yeah, sure. So I'm product marketing manager. I'm working for AI team in a central organization of STMicroelectronics. And okay, very pleased to be with you today to speak about one of our favorite subjects.
Awesome. And then John, over to you.
Yeah, hi everybody. John Marconi, VP of Technology at Embed. I lead up all of our AI work, so it's nice to be here.
Awesome. So to set the context of who we are talking to, I'm going to hand over to John and Vincent for a brief introduction to their respective companies. John, I'm going to start with you. Could you introduce EmbedUR to us?
Yeah, absolutely. So EmbedUR has been a company for more than 20 years at this point. And during that time, we've been doing a lot of work on connectivity, embedded development. We worked for a lot of large Fortune 500 companies, kind of making their products better, sustaining their products, and essentially, making solutions that are kind of ready to go out into the world. In the last 10 years, we've seen a big shift to AI development in service providers. We have systems that are basically helping manage their networks, provide intuition as to what's going on, how to make things better. And in the last 5 years, we've actually shifted that work from big centralized systems into edge AI. And so part of our company's focus is on our ModelNova brand, which is basically where we work across solutions that are basically bespoke for customers, as well as products such as our ModelNova Model Zoo that we work across chipsets to provide basically ideas on how edge models can work on different hardware platforms, and our Fusion Studio tool to help retrain these models. One of the products that we also have under this brand is our NovaEyeD product that we'll show today, that essentially is face recognition that runs on the STM32N6 platform. And we'd like to kind of demonstrate how that works, and as well as get in contact with us if you have other products or projects you're interested in. So thanks, Adam. Back to you.
Awesome. Thank you, John. Vincent, over to you. STMicroelectronics is quite a well-known name, but for anyone who hasn't heard of you.
Yeah, sure. Yeah, but maybe for those who may watch this webinar without knowing who is ST, we never know. So ST is a global company with almost 50,000 employees, with global revenue around 12 billion. But what is important, I think, is we differentiate from other semiconductor companies because we are creators and makers of technology. That means that we design, we manufacture, we test, we evaluate, and we do the global support of our products with our own foundries and our own backend infrastructure and offices over the world. Okay, and last but not least, also, we are a social and environmental friendly company with some membership in some key organization for this purpose. Let's move now to the different markets we address. So essentially, 4 big ones: automotive, industrial, and personal electronics also. And of course, the communication equipment. So for that, we used to say that if you live on Earth, actually, and daily, you are probably surrounded or using tens of our products. But if you also drive a thermic car, maybe that numbers goes to hundreds. And if you have a chance to drive an electric car, then it even raised to thousands. That's what we used to say as examples. Okay, now go to the products, because we have a large product portfolio. So essentially, we have some dedicated automotive products, power and conversion ICs, general purpose MCU and MPU, so microprocessors. So the microcontrollers are the purpose of this webinar. And discrete components, MEMS, and the image sensor, obviously, and the specific ASICs also for specific markets like satellite communication, but many others. Now I'm done, so back to you, Adam.
Awesome. Just before we move to the next session, must be funny because you're seeing me live and also me on the screen. I'm going to run our second poll of the session, and that is, what is your biggest hurdle when implementing embedded vision or facial recognition? So I'll give you about 20 to 30 seconds to answer this one. It's an interesting spread of results actually so far. It seems there are, of course, some people still researching, but a lot of people have answered hardware constraints. That's the memory, compute, and power, with some people talking about the model accuracy and data privacy. Well, the STM32N6 tackles all of those areas, and we're going to find out about that very soon. Back to the recording.
Back to you, Adam.
Awesome. Vincent, thank you very much. We're going to start with the first question, and it's a pertinent one. Over to you, John. So when we're building facial recognition in production, making a demo is easy, but actually putting it into production tends to be quite difficult. So where do projects normally stall?
Yeah, absolutely. Same thing as everybody. We see that there's open source, there's good examples of face recognition, models out there. But there's a lot of issues actually bringing those to production. First of all, if we take most of these models, they're designed for running on GPUs, right? They're server-based, they're large, they have access to tons of memory and tons of resources. And getting these models shrunk down for a processor like the N6, which is super powerful, but also not the same as like a GPU server system, is a big challenge. Essentially, the large models, the large amount of processing capabilities they need and the memory they need just aren't really well suited for a production system like the N6. So part of the challenge is getting those models shrunk down, and when they're shrunk down, making sure that they're still accurate. So when we talk about accuracy, there's a lot of things that go into that. We need huge data sets. We're talking about, maybe hundreds of thousands or millions of identities of people. And for each of those identities, we're talking about, possibly hundreds of images per person. And so those huge data sets are one challenge. What is the source? They might have been taken with high resolution cameras. They might have, not much variation in lighting or background. And so when we get to the real world, all of those things, like you can imagine, your front door of your house. What do those people look like at nighttime? What do they look like at daytime with the sun, behind their heads? What do they look like if there's a bright light overhead? So all those different variations are things that you have to account with your data set or with augmentations. And it's a huge gap from something that is just kind of ready to go, open source, kind of off the shelf, to something that actually works on your sensor, on your chip, and in your actual use case, which can have a lot of variation from what those open source models provide.
Awesome. And then now we've heard a little bit of sort of, why it's so difficult to deploy and build facial recognition. Vincent, how is the STM32 ecosystem and the wider market evolving to meet the demand for on-device vision AI? And I'm going to hand over screen share to you. So if you want to share your screen, walk us through what you guys over at ST are doing.
Okay, well, so about embedded AI adoption. So I'm sure, like me, you are spanned by news about the revolution on ongoing Gen AI, right? So, which is absolutely awesome, but this big elephant in the room should not hide the other revolution that is currently happening at the edge, that is called the embedded AI. And I think it's also important to observe the dynamics and the metrics on this adoption. So what we can see on this chart coming from Yole, that is focusing on edge AI adoption for the MCU, we can see that the AI algorithm overall, they are more and more used across the MCUs with an estimated CAGR of 15% for the period 24-30. And what I think is interesting is that AI is growing, but not only in AI accelerated MCUs, but also in conventional MCUs that are leveraging or not the Helium vector extension. This is due to the pervasion of AI across all the market segments. So with computer vision, of course, example and application, but also audio, and we start some light AI for sensing application also coming up. So what I suggest now is that we have a look on the flagship microcontroller of ST for the high performance AI. That is the STM32N6. Sorry. So let's focus on this chip that is addressing the most computation extensive application. So it's the first microcontroller from ST featuring our proprietary neural art accelerator. What is it? It's a neural processing unit enabled. So it's enabling AI-driven application on an MCU, and it's also the most powerful MCU today to address the computer vision application. So let's discover now how the N6 changed the game. Okay, this MCU combined the best of two worlds, the MPU world, so the microprocessor world, and the microcontroller world. For the end user experience, it's closer thanks to the neural processing unit of a microprocessor with the AI capability. While it still benefits from the advantage of a microcontroller with small footprints, lower power consumption, also lower cost with lower PCB, and a lower bill of material due to the reduced number of external components like regulators and the faster boot time. That's very important. Okay, so let's see this device in action. So overall, running AI on this MCU thanks to the neural processing unit reduce the CPU load and increase the frame per second and speed of operation of the AI while remaining much more power efficient than a microprocessor. So this is typically application that you may have discovered 10 years ago running on Jetson Nano with the same level of performance that is now available on a simpler MCU. The N6 is a game changer for running AI application. It provides the 600 GOPS for the AI, which is 600 times, by the way, higher compared to what we got so far with the STM32H7. It has a Cortex M55, so it's an hybrid CPU with DSP extension running at 800 MHz. It embeds 4.2 megabytes of RAM, which is the largest amount of RAM available on STM32. This large number means that for an AI application, for instance, you can run it without having any external memory requirement. There is a hand-to-hand camera pipeline, including the MIPI CSI interface, an hardware ISP, and also you can use the graphics capability for that chip with the 2.5D GPU and H.264 encoder and all the security features. That's overall a very complete product to address AI, but also many other applications. So let's focus closer on the today application for face recognition, and let's see how to dig a little bit in the camera pipeline. So the camera pipeline supports up to 5 megapixel camera, up to 30 frames per second. As I said, with the connectivity of MIPI CSI, it's a dual lane MIPI interface but it's also possible to connect it with a parallel interface. So the ISP includes blocks like decimation, demosicing, contrast enhancements, and much more. But also the statistics extraction that are very important because they enable to do some auto white balance and auto exposure that are delivered through the st.com. So in addition, where there are three different possible outputs to address simultaneously, for example, the GPU or the NPU or the encoding part. So it means that you can have image with different characteristics of your image and send it over all these different units depending on your application. So let's move to a next page about the ISP tuning software, one of my favorites. So ST offers a unique ISP tuning tool available on st.com for free that is called STM32 ISP IQ Tune. That's the first software tool for microcontroller to be able to tune an ISP for a particular CMOS image sensor and its length without the need of external or third-party expertise or internal but very extensive expertise from your company. So in essence, it analyzes the image quality, color accuracy, and image statistics. Then it will program software that is running on the STM32N6 that is interfacing with the ISP. So it's very simple because it's the step-by-step software. So you can tune quite easily the ISP to have the best image experience out of your image sensor. Okay, and last one, and I cannot finish this presentation without mentioning it. It's a great space on ST Edge AI Suite. It's a kind of catalog of use case where you can find today more than 70 use case with technical description and metrics for each of them. And we have the one with embedded UR for the face recognition, and yeah, according for some customers, it's a very useful tool to start project, give IDs, and be able to select the STM32 platform. So feel free to visit this nice space. And okay, now I will revert to you, Adam.
Awesome, thank you very much. So I'm going to steal the window back from you. John, I'm going to throw this back at you. Now we've defined the silicon, the STM32N6, but how are we actually going to implement facial recognition? Well, I hope that's what you're going to show us. So I'm going to hand over screen share to you, sort of like a moving train. Feel free to share your screen and tell us a little bit about NovaEyeD.
Yeah, absolutely. So yeah, thanks, Vincent. So you know, these chips like the STM32N6, they're pretty powerful, and we can actually do a lot of processing on this MCU with the NPU. You know, things that we're doing here are not capable of being done, you know, without such a powerful chip. So in NovaEyeD, which is our face recognition product, we have two different paths that we take. First of all is registration. So essentially, you don't have to train the model to understand each person. So for instance, I didn't have to load up my face and then train the model to understand it. Essentially, these models are designed so that they can learn what a face looks like to an extent. And registration is something that can happen either on the device. So for instance, I'll show you in the demo where we actually register it on the N6 itself. And you can also do it remotely. So you can do it from like a mobile phone. You can do it from a centralized server and then transfer it to the device. So there's different ways to basically get these faces identified, recognized, and kind of like accepted into the system. So in our registration, what do we have to do? So we first have to detect that there's a face in the image. So you can think about like your camera of your device is pointing. There's not a face there, but we want to register it. It first needs to find the face. So we have one model that basically finds the face. And then there's the angles. So if you ever go to like TSA or any of these places that are, checking your identity, they always have something that says, "Hey, put your face into this frame." We want it to be upright. We want it to be close enough. We want to do all this stuff. And one thing that we don't have that luxury on the N6. So you can actually imagine some of these cameras. For instance, if it's in a doorbell, if it's in an appliance. You actually don't get that feedback. You don't know what angle the face is at. You don't know when you're registering that it looks right. So our system actually has to adjust for whatever the angle of the face is. If it's tilted this way or forward, we basically handle all of that so that we can get a good registration for each of the users. The next part is the quality check. So we need to make sure when registering that the face isn't obscured, they're not not holding their hand over their face, that the lighting looks good, that they're not kind of like slouched over. So all these different things we basically ensure are happening in our registration pipeline, that we're getting a good quality face to look at. Finally, we have to extract the embedding. So we have to essentially run another model that does the recognition pipeline. And what this model is doing is it's saying, okay, let me capture images of this face. Let me understand the fingerprint of the face and spit those out as raw vectors that we can basically use. And we capture these embeddings at different angles. So we have the user look forward, look up, down, left, right, and capture what their face looks like at different angles. And that becomes essentially the fingerprint for that person that then we store into Flash or on disk, so that we can essentially look this person up later when they come into the view. So that's registration. The next part is recognition. So now you've got these faces stored. You might have 1, you might have 100. And on the N6, the fingerprints for the faces, the embeddings are fairly small. So even in the Flash on the Discovery kit, we can store hundreds and hundreds or thousands of faces and then look them up. So again, part of this process for recognition is very similar to registration. We first have to detect the face. So versus registration, in recognition, we can actually detect multiple faces. So you can think of 5 people walk up to your doorbell, and you want to know not just who one of the people is, you want to know who all the people are. So in our recognition pipeline, we actually are looking at every face, finding every face in the image. And then we're basically, going through each face to recognize who that person is. Part of the checks here, this is an optional one depending on the use case, is a liveness check. So we want to know, is somebody holding up a photo? Are they holding up an iPhone with a picture? Or is it an actual person? So this is a pretty, you can also, there's another term for this called anti-spoof detect. Basically, we want to make sure that, somebody walking up is not pretending to be somebody else or using something to pretend to be somebody else. And this is where, when we have access control systems, this becomes very important. You basically want to make sure that whoever's in front of that camera is a live person and you're identifying them properly. Again, we have this align and warp, essentially getting the face into the right position for the recognition pipeline. And again, we don't have the luxury of telling people to put their face in a certain place from a doorbell. So we need them to, just look however they look, and then we'll basically do that alignment to match their face. And then for every one of those faces, we go and we extract. We determine the angle that their face is at, we extract the embeddings, and then we are basically matching them against our stored database of faces. One thing that happens though is, periodically people's faces, change. You can think of people growing beards, maybe they lose weight, gain weight, maybe they have contacts in. So when they register that first time, we basically gain like a fingerprint of what that person looks like. But over time, it can actually shift a little bit. And so we actually have like a periodic check to see if there's a little bit of drift on those embeddings on their fingerprint and kind of adjust them so that we kind of keep up to date with how their look is. And then finally, one of the important parts of this is the APIs. So we know that face recognition is not just a standalone system. It has to integrate into an application. So you can think of like an access control system. You want to know that there's somebody live in front of the system that matches Adam's identity, let them in. Or you want to know that there's actually somebody that is holding up a phone picture of Adam and you do not want to let them in, but you also want to let the system know that somebody is attempting to do this, right? Maybe capture a frame, so you can see who's trying to do this. So all of these things are managed with our API system that lets our application have the intelligence to know what to do about any situation that the face recognition is seeing. So what are the metrics for our system? So this is pretty low power. I mean, again, we're running on an MCU, and we're basically running around 40 milliseconds per frame. So that includes the detection, the recognition, the anti-spoof checks, the liveness checks. And so we can actually process a lot of frames per second. And when you're looking at a static image, somebody standing there, it works for that, but it also works for people kind of just walking through the frame to collect their images. We're also using pretty low memory. So I think Vincent was mentioning 4.2 megs of SRAM. We're using less than half of that. So part of the thing here is we need to basically like cycle through our models. We need to optimize the system to actually fit in the constraints of the N6 and still allow enough space for applications to do their processing. So we try to keep that amount low. To make sure that the end customer can do whatever they want with the solution. It's also very low latency. So as I mentioned, even though we have like 15 frames per second here, we're detecting multiple faces. We want to make sure that if somebody pops into the frame, it isn't like it takes several seconds to detect who they are. We want it to be pretty seamless for the user and also have it be intuitive how to use and just fast. And finally, I know I mentioned that registration you can do remotely, you can do it on device. There's zero cloud dependency on any of this. You don't need any other processing offline. All the registration, the learning of the faces, the recognition is all done on the N6 itself. And so that's one of the keys to keeping, for privacy, for security applications, basically like these fingerprints of people, we want it all on device. We don't want it leaving the device. We want to basically make a system that people want to put in their house and they can trust that it's that they're not being their face isn't spreading out over the internet and to other places. So we have a very high accuracy. Again, there's different use cases. We handle indoor and outdoor. We have a very robust set of different cultures that are in our data set. Also handles things like hats and masks and all kinds of lighting conditions. All of those things are real world issues that you'll definitely find, depending on how you deploy it. So we need to handle all of that. And so we're hitting a pretty high accuracy with that. We have different modes that we can recognize faces. So I mentioned like maybe we see 5 faces, or maybe we just want to know who the user is who's right in front of the device. So you can imagine like if you walk up to your coffee machine, you don't want that coffee machine detecting somebody who's 3 feet behind you and making their coffee. You want it to make your coffee because you're right in front of it. And again, we have multi-face storage, so we can store many devices. It's pretty low size template for each fingerprint of the face. And like I said, we have the periodic embedding updates, and Everything is designed for real world uses. So that's the end of our slideshow. So back to you, Adam.
Hello, it's me again. I hope so far you've been enjoying the session. I just want a quick update. Just remember that we will be doing a live Q&A session at the end of this recording. There's a few questions that's come in already, but be sure to ask more in the top right of your UI. I have our third poll I'd like to ask you guys in the audience, and that is, where does your team struggle most when implementing embedded AI? And at the end of this poll, we'll get to the part of the webinar you've most likely been waiting for, which is the live demonstration of NovaEyeD. So I'll give you guys about 20 seconds to answer this. I see a question that's been put already. Do you have the slides downloadable in PDF for our colleagues? There will be a recording of this session sent out immediately after the end of the session. So if you'd miss anything and you'd like to go back and visit the slides, that will be available to you. I'll give just about 5 more seconds. Awesome. So we have actually a very even spread of what the main issues are across every single category. So without further ado, let's get into the live demonstration of NovaEyeD on STM32N6.
Back to you, Adam.
Awesome. John, thank you very much for that comprehensive overview. But you know, that's the theory behind NovaEyeD. I think it's time we actually see it live in practice. So for everyone in this session who stuck around, I thank you very much. We're sort of just over halfway through the session, about 35 minutes. John, I'm handing back to you again. So we've just come from you and I'm handing back to you. Let's see it running live on the STM32N6.
All right. Before I go live, I want to show one thing because I'm only one person in a room here. I want to show how this can work with multiple people. So here you can see is the N6 itself, and we're basically going through a registration process right here, where again we're capturing the embeddings at different angles. This user gets automatically assigned a name. So obviously, like, we would want to put his real name into a product if we can, but when you're doing everything on device, we basically assign a pseudo identity. So we have a second user coming. Again, the registration process just takes a few seconds. Got our second user, Bravo. And by the way, everybody who runs this demo, they always want to be the alpha user, never the Bravo. Here comes our third user.
I just want to say this is awesome.
Okay, so there we have Charlie. So now everybody else will come back in the frame. So now the system is actually detecting all three users at the same time. And so that it took just a few seconds to register everybody, and obviously the detection is also pretty fast. So I'm watching myself, but here we have a system that's basically running, and it has nobody registered on it. This is a N6 just sitting here on my table with me. And I'll kind of show you again the pipeline of how this works. So like I said, the first part we want to do here is register. So we'll just click on this button here. Basically do that. Okay, so now I'm the alpha user, yay. So here we are, it's detected me. We want to basically make sure of several things. So I have some pretty big that the system is still detecting me with and without, glasses, accessories, basically anything that might vary from one time a person uses it to another, can create complications with recognizing somebody. So one of the big challenges of productization, like we were saying, is how do we make sure that we can account for all the different ways a person might look day to day. So I kind of showed that a little bit. And by the way, you can see that this is running around 15 frames per second when it's recognizing me. So it's pretty fast. If I cover my face, meaning it's not detecting any faces, it's around 30 frames per second. So that means it's still doing the detection 30 frames a second, which is also the camera speed. Let me show one other thing here. One other big thing that we have is lighting variation. So you can imagine like when we have like a doorbell or something like that, or even inside, we see that there's a lot of light variation that comes in to like a natural scene. And we need to make sure that essentially the system can handle those light variations pretty strongly. So both there's the face is too bright, the face is too dark, and our solution actually handles a pretty high level of lux levels. But we actually are tied in pretty closely to the camera subsystem as well as the ISP, because we need to do things like handle auto exposure, handle, for instance, like if your whole background is like the sun shining from behind you, and your face is actually kind of dark. What we'll see is that the face becomes like pretty dark when the auto exposure kicks in, versus the background. And then it could be reverse, right? Like maybe the face is really bright, the background's really dark. So all of those different things are things we have to account for in our system. Part of it's with the data set, part of it is with essentially like image processing that we do, and also part of it is working with the ISP to get the best exposure for the face. So that was kind of the demo that just myself, but let me do one thing here. So I turned on our liveness detection mode. So you can see here that my face alpha came up. It's showing me as being a live person. But I actually took a photo of myself earlier. And so this is actually, me in the same, you can see the lighting is a little bit different, but essentially it's actually detecting that that this photo here is a spoof. It's not actually me. It's somebody pretending to be me. And so this is, I have another one from the other day. So again, it kind of looks like me, but the system is able to say, no, it's not actually John. And
That's having a lot of fun recording the mugshots.
Which is okay. Okay, and here's a video of me that I took. Again, the same thing. It looks just like me. It knows that it's trying to be me, but it also says this is not exactly John. This is somebody pretending to be John. So these things are key to making sure that this kind of technology can be used for secure purposes. And it's one of the things that we've spent a lot of time to develop and make sure it works really well. So when you want to put this into something like a industrial machine that only allows access to certain people, it's going to work, and it's not going to let people in who shouldn't have access. So yeah, that's the overall demo that I have. So yeah, back to you, Adam.
Awesome. So thank you very much for that, John. We're now going to move to the second half of the discussion. And the first question I want to ask is, what do engineers underestimate when building an embedded AI product? Vincent, I'm going to put this one to you first.
Yeah. So that's a good question. And you're right. What is difficult is when you are moving to an MVP and try to make an industrial product, and everything is between these few % of improvements that you are trying to get, but actually that's very can be complicated, and sometimes we don't realize what it implies. So there is several aspects. The first one is probably on your demonstration or MVP, you are using everything with a public data set first or synthetic data. which are fine, but not exactly in the same scene illumination or condition that you will get in your final application. So it's important to record some new image that are likely to be recorded with the camera that will be used in the final product, but also do some curation on the data set to make sure you will get this a little few % of improvement at the end for the AI inference. And the second aspect is regarding the compression and the how to get from a model that sometimes are coming from 32 bits floating points, and you need actually to make it run on STM32 product to be in integer 8 formats. But to do that, sometimes it can be you will need to modify a little bit the architecture of your neural model and refine the hyperparameters. So all that tasks that are small adjustments of your model, your AI, but that will make all the difference compared to just a demo with, let's say, good enough performance. That's very important. For that, okay, ST offer some tools like the Cube AI Studio to do the compression easily and without knowing that you are using the NPU at the end of the STM32N6. But okay, that just I want to say that okay, there is tools existing on ST, but yeah, there is some important steps that has to be done, and of course when it's done by a company like Ambedua, so with a production ready product is much simpler for many customers. Yeah.
And John,
okay.
Very briefly, anything to add to that?
Yeah, I mean, I think from our point of view, we see two types of engineers, typical AI ML engineers, right? That they are very good at the model side. They know what's state of the art. They know what works well. But then the challenge is how do you bring it to a small device? The models may need to adjust. The data set may need to adjust. The camera sensors look different. All those things that embedded guys kind of understand because they've been working with that technology. The AI folks like kind of need to, get into that mindset. And then similarly,
awesome.
from the embedded side, those engineers understand a lot about, the performance, the tuning of the firmware, the drivers and such. But then the AI side, how to fit that in is kind of a challenge. So we basically see like the best types of solutions are where you marry those two, the embedded side and the AI side, and have a team that's kind of focused on creating like a holistic solution. And that's kind of like why I think Vincent is kind of mentioning about the productized things. Part of what we do here is marry those two worlds up so that end users don't have to figure those different aspects out themselves.
And John, thinking about products, what are some of the best applications for this setup?
Yeah, so I kind of mentioned a few ideas before, but the idea I always think, and I actually really want this, is my espresso machine in the morning. I basically don't want to have to walk up to it and have it hit menus and figure out what I want to make. I want it to basically like just see my face and then make my coffee the way I like it to be made. And same thing for my wife. Like she likes hers a little different, so I'd like it to automatically figure that out. So I think appliance use cases are pretty strong for customization. I also think that again, doorbells, like everybody's got these smart doorbells today. And they're becoming a lot more sophisticated in what they can do. You know, I actually do want to know, like, are my kids in the front yard? Is there somebody else in the front yard? All these kind of alerts, and access control, and basically like giving me some insights, so I don't have to, you know, constantly be looking at the camera, is another like super good use case, as well as, you know, any kind of access control. Again, I mentioned like industrial systems. You can imagine like some heavy machinery that only a couple people are in the facility are kind of licensed to operate. You want to make sure that only those users are going to have access to the systems, or medical devices. You can imagine people, you know, nurses, who are operating pumps. You know, you want them to have access to control them, but you don't really want the patient's family to be able to control them, as an example. So there's all kinds of use cases there that range from things that are very secure to things that are kind of more just customization that that this type of product can go into.
It sounds quite a wide gamut. Vincent, are there any other ideas you can add to John?
Yeah, no, I totally agree. This is typically this kind of application I am seeing from customers. So basically two kind of application: the access control with, as you mentioned, some application in the hospitality and residential, and also for, let's say, customization in general, either it's for your coffee machine, home appliance, but I saw see some example for gym equipment, to make your own program, and not the same of your wife. Yeah, so this kind of application are actually very. I receive a lot of requests for all that verticals.
Awesome. So lastly, John, over to you. If I've got a project myself and I want to use this workflow, I want to evaluate NovaEyeD, where do I go next? How do I get started?
Yeah, absolutely. Reach out to us and request a demo. We'll be happy to show you, like, live running on the STM32N6 platforms.
Awesome. And then with that, we come to the end of the pre-recorded part of this session. As John mentioned, you can get in contact with them, and on the next slide, on the Q&A slide, there will be a QR code on your screen to get you started with NovaEyeD. I want to thank, using the clap function, Vincent and John for sort of pulling back the curtain on an embedded vision solution today. Now, we're going to transition to live Q&A. But just before we go there, one little point of note. Be sure to fill out IP Exchange post-webinar survey. So for those who've been here before, or if you're new, we always try and make these sessions entertaining, well, educational, informative, and perhaps on your Tuesday evening, entertaining. So we'd love your feedback. Please let us know. I'm now going to hand over to Adam in the studio right now to take us to live Q&A. And almost as if by magic, Adam in the studio is here to take over. We're now going to transition to a live Q&A. I'm going to bring back John and Vincent into the session. We've had a bunch of questions. Just before we get to them, I'm going to ask our final poll of the day, which is, when do you plan to deploy a vision-based AI model in a commercial product, if at all? So I'll give you guys 20 seconds, and then we'll get right into the Q&A. Brilliant. So we've had a wide range of responses again, quite a few people in research, but actually to the 6 people who have a project on your desk right now, this might be the perfect solution for you. So let me go straight to the Q&A. And as promised, we have the QR code in the bottom right of your screen if you'd like to access, if you'd like to access NovaEyeD for yourself. So I'm going to start with the questions. Vincent, my first question is to you. Is there any code available to test with the STM32N6570 Discovery kit?
Yeah, so yes, absolutely. This is something we can we can share. So this demonstration you just have seen, of course, you need to ask to ModelNova, but yes, this is exactly the same application that you can get on your desk, and feel free to try in different conditions. And yes, so that's not on st.com because it's coming from partners. But yeah, you have all the information on the ST authorized web page to get access to that one, and just make your requests.
Awesome. And then John, over to you. NovaEyeD at the minute, we've seen it being used for human faces. Is there any possibility now or down the line to recognize, say, animal faces?
Yeah, that's an awesome question. We do have some special trainings that we do for things like recognizing your own pet. For instance, like one of the use cases is like a pet door that you want kind of automated. So this same technology can kind of be the basis for that. But again, it has to go through the whole productization life cycle and kind of vetting in different, lighting and all that kind of stuff. But for sure, it can be used in that way.
And then staying with you, John, with NovaEyeD, how are you managing sort of the current incremental improvement in MPUs and DSKs?
Yeah, it's a great question. So we do have a team that is basically dedicated to the N6 work, basically understanding, what are their improvements, what new operators are they supporting, how can we like squeeze the model down to fit better, to run faster, things like that. So those improvements the team is working on constantly. And so I think that's one of the things that we maybe talked about is like for a POC that you just want to see something working. Maybe that's not important, but we know like our customer base is gonna, start, next year, and they're not going to start from something old. We have to basically keep up to date with the latest on ST to make sure it's going to be viable in the future.
Awesome. And this is sort of to you, John, but maybe Vincent might have something to say here. Let's say that a device is physically damaged or stolen. Is the facial data encrypted on the device?
Yeah. So we're not actually storing images. We're storing kind of like, I'll say, fingerprints or breadcrumbs about what a face looks like. The data will be encrypted on the device. So obviously there'll be ways that we can access it and use it at runtime. But once somebody wants to take something and off of a house, for an example, if they drill into it, they're not going to get access to those face embeddings.
Thank you. And Vincent, over to you. With the STM32N6, is it possible to use SimSys CMSIS development environment? Are there templates?
Yeah, it's absolutely, it's possible, as it is a Cortex M55, so it can either run, so the AI can either run on the neural arts NPU, or it can also be using the extensions from ARM. So yes, that's absolutely feasible.
And then staying on you, Vincent, where does TinyML fit in with the STM32N6?
That's typically the product, I think, to run a tiny ML application for computer vision. Is in essence because it's thanks to, I mean, the ISP, and to have search capability in terms of AI. So it's really well fitted to address very low power application while getting a high level of performance. So definitely the one product for TinyML applications. Yeah.
Thanks, Vincent. We're just over the hour, but we'll keep going for about 5 more minutes. There's a lot of questions to get through. John, back to you. Can you do any level of registration with a single picture, let's say, for example, like an ID photo?
Right. So we do have so our system is pretty flexible in that way. So I think during our demonstration we showed, the faces looking around, but you actually don't necessarily need that for every use case. You can think of, like maybe like an access control system where you basically are walking up, you just want to stand right in front of it, have it recognize your face, facing forward. In those type of systems, we can actually use like a single photo and actually input that into the system and capture the face. And we have a demonstration of that running in our facility actually, where we actually log the attendance of the employees coming in, and it's based on some database of faces from our HR system. So definitely flexible that way. It just depends on privacy and how do you want to manage all of these, the personal information.
Thank you. And what's the current maximum supported number of faces or users with NovaEyeD?
Yeah, so the actual face data that we're storing is between 500 and about 2,000 bytes.
Wow.
So on a flash, we can fit thousands of faces, or even tens of thousands of faces, and we have a way to efficiently look those up. When the a user comes onto the screen, basically search through that pretty quick. So there's not you're more limited by the resources on your design, your hardware design, than by what the algorithm is doing.
Awesome. Thank you. Vincent, back to you. What would be the current best tool to move, say, an existing Python program to actually execution on the STM32?
Yeah, so in addition to the hardware, we also develop a software, AI software offer that makes it easy, and you don't have to take care about compiler, this kind of stuff, because we actually offer what is called Cube AI Studio. That is a tool where you come with your model, or you take one from our ModelZoo available on GitHub, and you use the tool to have the model convert in integer 8 bits, and then it will automatically generate the C code that could be easily integrated into your project for AI. So yeah, that we deliver such kind of very useful tool, and it supports models like ONNX model or TensorFlow. Yeah, so very large number of models can run on it.
Very quickly, Vincent, could you repeat what that tool was called?
So we have the LightRT is the new TensorFlow format. Then we have the ONNX format. Okay, that is supported.
Awesome, thank you. John, back to you. Let's talk about the performance on the lighting. I know we saw like a little bit in that demonstration, but to what extent does lighting quality and CRI have on the actual accuracy of the model?
Yeah, absolutely. So that is where I would say we spend a majority of our time actually on this model is understanding the different sensors, what type of capabilities they'll have. Some will have auto exposure, some will have IR inputs, and so we basically need the model to be pretty flexible. So you can imagine, like again, like a doorbell camera. This device is going to be pointing out at in the middle of the night, and you might have lights from the house like near it, or you might not have any real light. And then you might also have the bright sun shining behind people. So we've spent a lot of time with our curated data sets, as well as image processing, as well as working with the sensors to basically like enhance those faces enough that we can pick out the proper recognition characteristics. So we do work down to about like 40 lux, and as well as to like full sun, maybe like 100,000 plus lux. So, but again, like there'll be some dependency on the sensor you're using, whether you're using IR, the resolution, things like that, that kind of come into play. But we're flexible enough to work across fairly large set of lighting conditions.
Awesome, thank you, John. We're going to have 3 more questions before ending the session, and they are all to you again, John. Does the system rely heavily on being able to see a user's eyes? Would it work when they're wearing, say, for example, sunglasses?
Yeah. So there is part of the part of this pipeline that is basically picking out face key points. So it's kind of looking at your nose, your mouth, your eyes, and it uses that to figure out like the orientation of your face. So if I'm tilted this way or this way, or this way, basically you need to get that face into a proper orientation for the system to work. So specifically when we talk about eyeglasses, the models that we're using for these key points actually are trained with sunglasses, or like eye coverings specifically. So we're able to like the model's able to essentially like figure out where the eyes should be on the face, to basically align it properly for the model. So no issues with sunglasses.
Awesome. And then what happens if the photo took up like the full frame in front of the camera, versus being able to see like the edges of the photo or a phone held by someone's hand?
Yeah. So there's a bunch of different processing we're doing with the anti-spoof or the liveness detection. A part of it is model based. So there's some AI models that are running. Part of it is based on like the coloring of the scene versus the background. So obviously, like if you stick a photo up there and it takes up the entire picture, we'll have had some data that we're capturing over time to see that like, hey, this looks totally different than what I just saw. And so like we'll have some the models and the algorithms will have some understanding that there's a change there. But there's also other parts of what goes into that photo, like the pixelation, the kind of fuzziness, that also is being used. Plus, we can also integrate with, if you have a sensor like ST's time of flight, or something else that can kind of tell like a proximity. Usually, you have to hold those things up pretty close to the camera. That isn't quite as natural for your actual face. And there's obviously like on a piece of paper, there's not really any contour to like the facial features that you would get from some of these sensors, if you had them available.
Awesome. And then my last audience question is, roughly how much more power is required when you're running this recognition compared to when it's in an idle state?
Right. So it depends on how you want to run it. So there's ways that we can basically optimize this. So for instance, like when you detect a face, you don't actually want to run recognition until you detect that there's a face on the screen. And that face recognition or the detection part, you don't have to run every frame, right? You could actually run this once a second. And depending on your use case, you can keep it pretty low power by having like a set of different gates that you need to follow before you run different models, before you do all this extra processing, before you know that you need it. So for sure, it can be flexible with reduced power usage. We can run this with a battery, for instance, and just keep the processing pretty slow. As well as one of the things that we do is if you wanted to recognize a face, you could either just send an event, or we can actually track it on the screen, meaning I've already recognized that Adam's face is on the screen. So rather than keep detecting that it's Adam over and over, I can basically track that your face is moving around the image and track it that way. So there's different ways that we can adjust for the power consumption needs.
Awesome.
Yeah, this chip is great for that. Is that if you have everything on, like the video encoder, the display on the screen, for instance, the camera and the NPU running on the same time, it's in the range of less than half a watt, more likely 300 milliwatts. So it's very low power compared to a microprocessor, for instance.
Awesome. Thank you both. I actually lied, John. I have one final question, which is NovaEyeD ready for my projects today?
Yeah, absolutely. So we're already going into production on several systems. So there's a lot of different use cases that we're targeting. We've heard some interesting ones like, hey, can you put this into drone technology? So yeah, we're going into production. Bring us your use case. We'll tell you where we're at. But we're already in the range of customization to secure authentication. So we're happy to talk to you about your use case, and I'm sure we have a solution that we can provide.
Amazing. That is all the questions we will be asking in this session. I've tried to get through as many of them as I can. If we haven't been able to get to your question, please answer our post-webinar survey, particularly the bit that says, would you like to have further contact with either ST or EmbedUR, and then you can send your questions directly to them. I hope this session has been informative and has been useful for you. The only thing left to say from us at IP Exchange, at EmbedUR, and at STMicroelectronics is have a wonderful rest of your day. Thank you all.
Thank you.